Okay, so now with that preamble, we'll be moving to, you can say, the second part of our discussion. Still, we are in the same topic, objects and classes, right? But now you have seen some basics of how do you make a class, what is a class, what is an object, what is a constructor, and how you can call functions of a class using the dot operator, right? So now we'll do some related discussion. That assume that the class is already there, some class point. Okay, so I'll not be making the class again. Maybe I'll be focusing on main for this discussion. Okay, so you see, you are you have already seen that for the time being we are doing something like this, say point p, and then you can write p dot, say, print or anything. Okay, this we have been doing. Now p is an object of point, we already know that, right? But you see, just like we do with basic data types, that sometimes we can write int x is 5 and we can display it, right? So it is equivalent to what we have written here. But in some cases we also need an array of integers, right? Maybe I need 10 integers. So instead of having 10 different variables like x1, x2 up to x10, I can simply declare 10 variables in a single statement, int a10, which means that there are 10 integers. The name of the first integer is a0, second is a1, and so on. I have till a9. So these are the 10 integers I have. And normally when we are using array, it is a good idea that we use a loop, right? So that we don't have to repeat it every time. So if I have an array of 10 integers and I want user to enter values for that, so instead of writing 10 statements, what I will do here, I will write for integer I is 0, I is less than 10, because 10 is the size of the array, I plus plus, and here you can write C in, C out, whatever you want, A of I. Okay. Now suppose we want to do the same thing here, that instead of 1 point object, I need 10 point objects. Okay. So how do I do that? Just see this, the syntax is exactly the same. What is the first thing? Int. Int is a data type. What is the data type here? Data type is point. After data type, what do I have? A. A is what? Variable. So you take any variable, I call it, say, p. Okay, or maybe p1. And then within square brackets, you have the size. So you put the size. Now, what is this? This is an array of 10 points, right? Now, if I ask you directly, right, declare an array of 10 points. So it may be challenging for some of you, but a good way to do that is first see how you do it for integers. So for integers, if I need an array, I will do something like this: data type, variable, and then size of array. So everything stays the same. If you come here, this point is your data type, this p1 is your variable, and this is your size. Now you have declared 10 objects of class point. Okay, and what is the name of the first object? The first object is p1 0. Second object is p1 1, and the last object is p1 9. Now, if I ask you that call the print function for the first object, then how can you do that? You write name of object, then you put a dot, and you call the function, whatever function you want to call. So you see, this is very similar to this, that you write the name of the object, then you put a dot, and then you write name of the function. And instead of calling the function for one object, if I say, okay, call the print function for all the 10 objects, then you see you can write 10 statements. But with an array, it is not a smart idea that I write 10 statements. I should be using for loop. So just like we did in case of integer, how do I do for an array of objects? For I will write I starts from 0, I goes till 9, I plus plus, and what should I write here? this is my object dot whatever function I want to call. So now you see, when the loop executes, when I is 0, you are calling the function for the first object. When I is 1, you are calling the function for the second object, and so on. So you can keep on doing it, and the function will be called for all of those objects, right? Just to explain this, let me write this program and show you the output. We already have the class available. Okay, we can just change our main. We already have a class in which we have a constructor and a print function. Okay, so instead of having a single object, let's say I want an array of point, right? So I write point p5. Now these are 5 different objects. Okay, now for int I is 0, I less than 5, I plus plus. Now what do we want? We want to set values for these 5 objects. You can also get input from the user, right? Say I write p of I dot set. What values I set? Say 2, 2. Okay, so you can do that, but now it means you are setting the same value in all the objects. If you want different values, so there's a very easy way. You can have 2 integers a and b here. You can see in them. Okay, and then you can pass those values to the set function, right? If you don't want the same value, you can do that, right? But since this is not our objective, so I kept it simple. And now if you want to print all of these values, okay, let me just make it simple so that we have fewer statements. So now if someone asks you that, okay, print all of these values, okay, so again you can do it in the same loop, but I'm just using another loop. Say point j is 0, j less than 5, j plus plus, and within this you can write j dot. So you are calling the print function for all the 5 objects. First for object 0, 1, 2, 3 up to 4, right? So this is the way you can use an array of object, which is, and in terms of syntax, it is very much similar to what we do with basic data types, right? Now let me just add one more information and then maybe we can have a discussion. So let's again go back, and here we have our main on the left side and on the right side. So in both the cases, what we do, we say, okay, normally when you are dealing with integers, you also have the possibility of having a pointer, right? We have been doing this, that p is a pointer to integer, and you can do this. You can copy the address of an integer in a pointer. So just like we can have a pointer to integer, maybe we can use pointers with objects as well, because object is just like a data type, just like integer is. Okay, so now suppose I take a point object, say point a, okay, and I ask you, I need a pointer to this object. So now just focus on this one. What do you do? Data type, static variable. What is the data type here? Point. Then you put the static and then you put a variable. Now compare these two, the one on the left and the one on the right. They are exactly the same. Okay. How do you read what is on the right? You read it as P is a pointer to integer, and pointer is a variable which holds address. We had done a comprehensive discussion on that in week number 2. So in other words, you can say P can store address of an integer, right? For this, what is on the right side of your screen. So it means I can copy address of any integer in P. Now, if you come on the left side, we have exactly the same syntax. So how do you read it? You read it from right to left. So you read it as P is a pointer to point. You see exactly the same thing. instead of integer, my data type is point. So if someone asks you, declare a pointer to class point, this is the syntax you use, right? Name of data type, which is point, the static for pointer, and then you have any variable name. Now, just like we can copy address of an integer in P in this case. So now you see in this P, which is on the left side of the screen, I can copy address of any point object. So it means this should be a legal statement. Now this statement is actually equivalent to this statement. You see, because in a pointer we can copy address. So in P, we can copy address of an integer if we are taking a pointer to integer. Very similar to that, if I have a pointer to my own data type, which is point, so it means now I can store address of any point object in the P, which is on the left side of the screen. And subsequently, we also discussed that if you want to print the value of X indirectly, you can use static P. Okay, if you remember, we discussed that you have to read it as contents of whatever is in P. We had a detailed discussion, and this actually is equivalent to X. Okay, so we said this is equivalent to X, right? Now, if you write the same statement for the left side of the screen, then it means static P here would be equivalent to A, right? So both of these are actually the same thing, that when you put static with a pointer, you are actually talking about, you are dereferencing it, and you are talking about the value, right? Just like we discussed. Okay, if you don't remember, please revise that discussion on pointers. Static P and X are the same thing. It means here static P and A are the same thing. So now if I want to call some function, so you see, if I call it with A, I use this A dot print. But what if I ask you that don't use A, call this function using P? We have just seen that static P and A are the same thing. So it means instead of A, I can write static P, and then I can call this function. So both of these statements, A dot print and static P dot print, they are actually the same thing. They are calling the same function, right? Because static P and A are the same thing. So if you have to call a function with an object, you call it with the dot. If you have to call a function with a pointer, you write static P, whatever is the variable, and then dot. Okay, this is one you can say syntax. For this, another syntax is, because you see you have to put static, then because of precedence you also need to put parentheses and then dot. So it is okay, there's no problem with that. But there's also a shortcut, or you can say a different syntax for that, which you can use, although this one is okay as well. If you prefer, you can also use that. And what is that? Instead of this, you can write the name of the pointer, which is P, and you can put this arrow. How do you put this arrow? On the keyboard you have this hyphen and this symbol, and then you can call this function. So both of these statements, they are the same thing with a different syntax. Okay, either you put static and dot, that is okay. But if you don't want that, you can simply write P and call the function rather than dot with this arrow operator, which is called the indirection operator. So let me just, since this is a lot of discussion, so let me write the program. Let me update the program with pointers, and then maybe we can have a question answer session. Okay, so we again come back to our program. We already have the class, so we'll be focusing more on the main. Okay, so let me just write, say, point A. Okay, and let me give it some value like this. Okay, and you know that you can call any function, say A dot print. Okay, so what we do, we write here cout printing the conventional way. Okay, so we already know that when you have an object, you write object name dot print, you call that function. Okay, now what we do, we say take a pointer. Okay, so how do you read it? P is a pointer to point. It means P can store address of a point object. So if you want to copy the address, we already know from our discussion on pointer that address of A is copied in P. Okay. Now, if you want to call the print function of object A using P, so what you can do? Sorry, static P, because static P is same as A dot print. Okay, so maybe I can print something so that we know. So we say printing using pointer. Okay, we are calling the same function but with a different syntax. And I also told you that another syntax for this is that instead of using static and putting the parentheses and then dot, you can simply write p m. Now you see when I write this, it is giving me suggestion of two functions I can call print and set because they are public. So I call this function like this. Okay. Now actually we have three statements in our program. All of three are doing the same thing. So this one, which you see here, this is the conventional way of printing. And then we have a pointer p. So if you want to call the function, we have already said that static p and a are the same thing. So just you write a dot, you can write static p dot. Both are same thing, right? So this is calling the print function using the pointer. But since this notation, you have a lot of typing to do, static, then parentheses, then dot. So another syntax for this is that you simply write the pointer variable, then you put this arrow operator or indirection operator, and here you can write name of any function. So let's run this program and see if it is giving us the output which we expected, that all the three functions should actually be doing the same thing. Okay, so I'll try run it and then share with you the output screen. Uh, so this is our output screen. You see, first parameterized constructor is called because we put a cout statement in that constructor. Then we said printing the conventional way. What is the conventional way? A dot print. And then we are printing, or we are calling the same function but using the pointer. Okay, so with the pointer you can either use static or you can use the arrow operator. So you see all the three function calls, they are actually calling the same function which is displaying the value of x and y of point A. And since we said 2 and 3, so all of these functions are giving you the same output, and this is how actually things should happen. Okay, now we'll be looking at the last concept for today, right? And what would be that? That you see all the examples that we have done so far, we have given the body of the function inside the class, okay, which is okay. There's no problem with that. But once you are writing relatively larger programs and you are splitting your programs into multiple files, normally normally you will not write the body of the function inside the class. The function will remain a member of the class, but just like previously you have been doing that, you give function prototype and function body separately, same we will be doing with classes. Okay, and this is the recommended way of doing it. There is no problem with the way we are doing it presently, right? But since there is always a better way of doing things, so let's see another better way of how we can reorganize our point class by keeping the implementation of functions outside the class. Okay, but please do remember they will still be a member of the class. Okay, many students think that when the function is outside the class, it is not a member function, which is not true. It's only that the body of the function we have organized outside the class. Okay, so let me just write the same example with maybe two functions. So suppose I have this class point. Okay, now within the class I will only write data, which is say integer x and integer y. Okay, and in the public we have been writing the complete function definition here. But now what we will do, we will only write the function prototypes here. Okay, and then after the class ends, I will be giving the definition of those functions. So for discussion purposes, I will make only 2 or maximum 3 functions in this class. So I will make a constructor. Okay. But you see, instead of giving body, I just give the prototype. So you just write name of the function, input, and you put a semicolon, right? There is no body. Similarly, you can make another function void print. And again, you don't give any body. I just put semicolon. And maybe you can also have a set function. So you write void set. Only prototype is required, no definition. And then I close this class and I put a semicolon. Okay. So now what we have changed so far, previously all the definitions we were giving within the class. Now I have only listed the function prototypes. Now what I will do after this, when my class ends, I will now give the body or the implementation of every function. Okay, so let's start with the print function. Now suppose I write something like void print, and within this function I write, say, C out X and Y, and that's it. Okay, if we write like this, so you see, how do we tell that this print function is this one? Because if you write like this, your program might think that this is a global function, this is a standalone function, right? Another disadvantage is that you see a print function can be present in many classes. For the time being, we are writing programs in which we have one single class. But you can have a point class, you can have a rectangle square class, so a print function can be in any class. So how do we know that this print function is the body of the print function which was in the point class? So you see, this does not seem correct. There has to be some additional information that we need to tell that this is the implementation or the definition of the function print which belongs to class point. And for that, what is the syntax? We have an operator in which you put double colon. This is called scope resolution operator, which is the fancy name, but you read it as belongs to. Okay, so this double colon, not single colon, okay, this double colon, it is called scope resolution operator, but that is just a fancy name for what we want to say belongs to. So it means whenever you are giving the body of a function outside the class, we will make use of this operator so that we can tell that to which class this print function belongs. Okay, and how to use it, it can be slightly tricky, but I'll explain you. You write the output, okay, and then you have your function, whatever the function is, right? Before the name of the function and after the return type, it means here, okay, means after the return type and before the name of the function, you will put the name of the class to which this function belongs. So this function belongs to class point, and here you will put this scope resolution operator. Okay, let me just clean it and then I explain. So just to make it visible, yeah. So now you see what we have done. This is a new part we have added. Okay, where this part is added before the name of the function. Okay, print was the name of the function, and after the return type we put name of the class scope resolution operator. How do you read it? You read it in this direction: print function which belongs to class point, right? Because I told you how do you read this. This you read as belongs to. So we are saying print function which belongs to class point, and this is the body or definition of that function. Okay, so this is the only new thing, that whenever you are giving the definition of a function outside the class, you need this scope resolution operator so that the program knows that this is not a global standalone function. This is a print function which belongs to class point. Now let me write the body of another function so that you know, you understand correctly. So now let's write the body of the set function. So I write the return type. then name of the class, this, and then you have this set function, which is like int a and int b. And within the body, you just write x gets the value a, y gets the value b. So again, you see set function which belongs to class point. This is the body of that function. Okay. And since here we were writing prototype, so there is no need of variables. Even if you write a, b in the prototype, that is okay. But in our discussion on functions, we discussed that when you are writing the prototype, it's your choice. You want to give name of variables or don't, it's the same thing, right? So if you want, you can also give name of variable in the prototype, but they are not required. Now let me also write it for the constructor, because constructor can be slightly tricky. Okay, because constructor does not have a return type. So here I'll write the body of the constructor. Okay, so you see constructor, for the constructor, since there is no return type, so I write name of the class because there is no output. Then I put scope resolution operator and then name of the function. What is name of the function? Name of the function is again point. So you see this can be slightly tricky because you have point, then double colon, then point again. But if you understand it stepwise, it is very easy. This point which is here, it is name of function. Okay, and since it was a constructor, so name of function is same as name of class. And then this point here is actually name of class. Okay, and this double colon is actually belongs to. Okay, so now you see we have exactly the same working of the class, but the only difference is that we have put the body of the function outside the class. And again, I'm stressing that these functions are still a member of the class. Okay, we have only given their definition or implementation outside the class. Many students always have this confusion that when the body is outside the class, they get the impression that now they do not belong to the class. They still are members of the class. The only thing is we have given the body outside the class. Now let me do this change in the class we were making, and we'll see that it will not have any impact. So I'll just go back to our program, which is here. And what we'll do is we will change this class so that body of all the functions is outside the class. Okay, so this is our class. Okay, so now I will remove all the implementation from the class. I just give the prototype. So I write the name of the function and semicolon, no body at all. Similarly, for the parameterized constructor, for the set function, and for the print function. So now you see, this is our class. We have a constructor, a parameterized constructor, a set function, and a print function. And here, if you don't want variable names, you can remove them. If you want to keep, there is no problem with that. It's your choice, whatever you like. Okay, so we have 4 functions in the class. Now here, what I will do, I will give the body of each of these functions. Okay, so but let me first give for the print. So I will write void name of the class, scope resolution operator, print. And here you can give the body of the print, like whatever was cout, say x, and then and so on, right? Similarly, you can give the body of the set function. Okay, I'm just leaving it blank to save some time. You can just copy whatever was written previously, but since you are giving body, sorry, outside the class, so you need uh, name of the function, scope resolution operator, and then the body of the function. Similarly, for the constructor, you do like point. So here you give the body, x gets the value 0, y gets the value 0, whatever you like. And finally, you can also give the body point of the constructor, which is taking 2 inputs, and you can actually write whatever statements you want here. Okay, now let me just explain a bit more. So you see now this is our class definition. This is your data. and these are your functions. But now you see we have a very compact sort of class where only function prototypes are within the class. All the definitions we have put outside the class. Okay, so what is the syntax? Name of the function, output. In between you have this part which is new, which is name of the class, and this new operator we have seen today, which is called scope resolution operator. But to understand, you can read it as belongs to. So it is saying the print function which belongs to class point, and you have to do it with every function including the constructor, right? So now you can just like you were doing previously in the main, you can create objects of this class, you can call the functions, and it's perfectly fine. There is no problem with that. Now one last comment that why we are doing this, right? You see presently we have one single file in which we have everything. Okay, in the later programs what we'll do is that if we are making a class a point, so for a class we will create two separate files. Okay, one maybe we are not doing it today, maybe later, but I'm just explaining you. We'll create a file point.h and we'll create point.cpp. Okay, in point.h we will just give the class definition, that what is data and what are function prototypes, and all the definitions of the functions would be in this file which is the cpp file. Okay, so it means you can have another third file which is like main.cpp, in which you can create objects of this class and you can call the function, right? So now you see we'll have a very better organization of our program, where the class data and class function prototypes, they will be in a header file. The body of the function or the implementation of the function would be in a cpp file, and main will be in the third file. Okay, so for the time being we have everything in a single file, which is okay. But gradually, maybe in the fourth, or maybe this is the fourth week, sorry, maybe in the sixth or the seventh week, when we are writing a program in a lab, so we will split our program into multiple files. And the advantage is that suppose you make a class and you sell it. Okay, you say okay, you can use my class for time or anything. So as we discussed previously that C++ is not open source. Okay, so you don't want to give the implementation. So since the implementation would be in the cpp file, you can only give this header file to your client, and all of these codes maybe you can convert it into a dll or a lib file which is not readable. So the client will have only the header file. It means that the client will only see this part, that okay, what is the data and what are the functions, but what is the implementation or body of the function, that will be hidden from the client, because you don't want to share your source code. Okay, whenever you make an api, you only give the list of functions that someone can call. You don't give your source code to someone, right? So presently, when you have all the code in a single file, if you give this class to a client, he will also have access to your source code. Okay, so that's why when we are making some relatively larger programs, we'll be splitting our program into header file which will only have data and function prototypes, and all the implementation will be in a cpp file, right? But that we'll do at a later stage. I was just telling you why it's a good choice to do like that.